Hey, geometry students. In this lesson, we're going to be talking about a special type of right triangle known as a 30, 60, 90 right triangle. All right, now, before we get started, I just want to point out that this triangle up here on the right is made up of two of these 30, 60, 90 right triangles. Let's just take a look at this overall triangle for a moment. Anything special about it? Well, notice that the base angles are 60 degrees. Then I also have this top angle, and when I add together this 30 and this 30, I get 60 degrees on the top as well. This is a 60, 60, 60 triangle, this big one. And if I look at this again, I'm just going to notice that this is equiangular, and equiangular triangles are also equilateral. Notice this side is 2x, this side is 2x, and then this bottom side is x plus x, also 2x. Okay, so this is an equilateral and equiangular triangle. Now, if I consider when I split this triangle in half, that's how I get two 30, 60, 90 triangles. A 30, 60, 90 triangle is born from an equilateral triangle. It's half of an equilateral triangle. All right. In a 30, 60, 90 triangle, the length of the hypotenuse here is twice the length of the base of the short leg. Okay. Now let's just take a look at this short leg here. Notice that it used to be a 2x leg, but when we cut it in half with this line that bisected the top of the equilateral triangle, it cut it in half. So it makes sense that this short leg is half the length of the hypotenuse. So we would call this one x, this one 2x because it's twice as much. What about the third leg? So if I have x squared, my bottom side right here, plus b squared, I wonder what the value of b is going to be, equals 2x squared. Okay, that's a Pythagorean theorem applied to this side, and this side. Let's solve and see if we can figure out what b is. So I'm going to square. If I square, get rid of these parentheses, I have to square everything in parentheses. So it's going to be 2 squared x squared. And then I know that 2 squared is actually 4. So this becomes 4x squared. I'm going to subtract x squared from both sides. That's going to give me the following here. So if I get rid of x squared from both sides, I am left with 3x squared on this side because I subtracted one of my x squareds. Now I need to take the square root of both sides. If I take the square root of both sides, I get b equals 3 times x, because I took x squared and took the square root of it, so it's just x. So one side is x, one side is 2x, and my third side is going to be the square root of 3x. Let me just copy this down here. And those are the sides of my triangle. There we go. All right, square root of 3x, we'll put that inside so we can see it and make it bold so it's nice and it pops out. There it is. Okay. So here's how this works. Anytime I know one side of a 30, 60, 90 triangles, I can figure out the lengths of the other sides exactly. All right, let's practice this by working the practice problems. First of all, we need to look at this 30, 60, 90 triangle. I know it's 30, 60, 90 because the 60 degrees and the 90 degrees are marked. The last angle has to be 30. Anytime my triangle marks two of those angles, I can always infer that the third angle has to be the one that's missing. And then I need to find the length of each side of this triangle. Let's see. So y is going to be the one that's the longest. Let's see, y is going to be 2 times whatever x is, right? All right, so let's see, 1, 2, square root of 3. The short side is 1, the hypotenuse is 2, and then the other side is the square root of 3. That means 7 relates to x as the square root of 3 relates to 1. Here's how I'm going to do this one. 1 over the square root of 3. Okay, 1 over the square root of 3 is the ratio between the short side and the long leg, right? That's going to equal x over 7. Got to be in the same ratio. Now, when I cross multiply this, I'm going to cross multiply 1 times 7. 1 times 7 equals the square root of 3 times x. That's the cross multiplied version of this. Or x equals the square root of 7 over the square root of 3. Now, just like in the previous lesson where this came up, we can't leave a fraction with a square root in the bottom. So I need to multiply this fraction times the square root of 3 over the square root of 3. So I multiply the top times the square root of 3 and the bottom times the square root of 3. What I'm going to get is 7 square roots of 3 over, I'm going to put this in parentheses so we can see that it's together, 7 times the square root of 3 divided by, and then the square root of 3 times the square root of 3 is just 3 on the bottom. Now, if you want to rework this out and put these so that they're over one another and fractions on a piece of paper, you can line everything up better than I can on here. You could feel free to do that. But you should get 7 times the square root of 3 divided by 3 is the length of x. Now, some of you may have thought, wait a second, if this is 7, this has to be 3.5 because it's half, right? Well, keep in mind the double relationship is between the hypotenuse and the short side. It's not between the long side and the short side. That's a common mistake. So don't make that mistake. Always look at this diagram of the triangle. It always goes 1 on the short side. The hypotenuse is twice the length of the short side. And then the square root of 3 is always the long leg of the right triangle. All right, so that's the first part of letter A. Now I need to figure out what the short side is. What the long side is. The long side, y, is just going to be 2 times the short side. So instead of 7 times the square root of 3 over 3, it's going to be 14 times the square root of 3 over 3. Okay, I'll actually copy this, and then we'll do that. And that is going to be the answer to my question. Okay, so 7 times the square root of 3 over 3 is the short side x. To get the long side, I have to to get the long leg, I need to multiply the short side times the square root of 3. 7 times the square root of 3 over 3 times the square root of 3 is going to be 7 times 3 over 3, or 7. So that works out. And then the hypotenuse is just double the short side. That was kind of a harder question, but it's not really all that hard. We just have to think in terms of a 30, 60, 90 triangle. Next, find the perimeter of the triangle in simplified radical form here. Okay, so to find the perimeter, I need to find x and y. Y is really easy because it's just 2 times the short. It's 2 times the short side. So it's going to be 2 times the square root of 3. Let me just get rid of this extra stuff here. 2 times the square root of 3 is the short side, plus this. Is the hypotenuse, plus the short side is just the square root of 3, and then the last one is going to be the short side times the square root of 3. Well, the short side is the square root of 3 times the square root of 3. The square root of 3 times the square root of 3 is just 3. So this is going to be 2 square root of 3 plus the square root of 3 plus 3. And now I can add these together. 2 square root of 3 plus the square root of 3 is actually, so 2 times whatever the square root of 3 is plus another one of the square root of 3 is going to be 3 square roots of 3 plus 3. And that's my answer for B. Let's just make sure we got this right. 3 times the square root of 3 plus 3. That is the correct answer for this one. All right, and then down to letter C. A school's banner is an equilateral triangle. Use the Pythagorean theorem to find the area of the equilateral triangle. Okay, to use the Pythagorean theorem, I have to note that this side here is 7, and it makes a 30, 60, 90 triangle. So this is just going to be 7 times 14 times 1/2, right? 1/2 times 7 times 14. And then I need to multiply that times, hold on a second. Let me think about this. Use the Pythagorean theorem to find the area of the triangle. That means to use the Pythagorean theorem, I need to actually find the height of the triangle. So this is not as easy as I thought it was going to be. To find the height of the triangle, well, I don't even know if I really need to use the Pythagorean theorem for that. I could use my relationships here. So if this hypotenuse is 14 and I cut this guy in half here, let's just draw a line here to cut this into two 30, 60, 90 triangles. Okay, that means the base of this right here is 7. It has to be half. And the height is 7 times the square root of 3. 7 times the square root of 3. Okay. Now, I know that a triangle's area is 1/2 the base, 1/2 the base times the height. If the base is 7, okay, and the height is 7 times the square root of 3. Let me just make sure I got this right. So this side's 7, 7 square root of 3, and then 14. So this is going to be 1/2 times the base, this side, times 7 times the square root of 3. And then I need to multiply that by 2 because I have two of these little right triangles in here. So it's actually going to be 2 times 1/2 times 7 times 7 square roots of 3. So when I multiply this out, I get 49 times the square root of 3. Let's just make sure I got this one right because that felt a little weird, but it is correct. 14 times the square root of 3 inches. Again, how did I get that? Well, I knew this base here had to be 7. I need to take the base times the height to get the area, but 1/2 the base times the height. That gives you the area of this little triangle here. And how many of these little triangles do I have? I have 2 of them. So 2 times 1/2 times the base times the height. That's just going to be the base times the height. The base, from my knowledge of these triangles, is 7 here. And the height is going to be 7 square root of 3. Okay. Um, and then I multiply that by 1/2, but then I multiply it by 2. I end up with this. Letter D. Find the area of one triangular face of a pyramid. The faces of the pyramid are equilateral triangles with sides that are 12 centimeters each. Same thing, except I'm going to use 12 instead of 14. So it's going to be 12 times, let's see, let me make sure I got this right. So this side's going to be 12. Actually, this side's going to be 6. So it's 6 times, and then this side is 6 times the square root of 3. Okay. That's going to be 36 times the square root of 3. Um, I would have to multiply it by 1/2 to get one of the 30, 60, 90 triangles because the area of a triangle is 1/2 the base times the height. But then there's 2 of them, so I have to multiply by 2. So I'm multiplying by 1/2, and then I'm multiplying by 2. I end up with this. Let's just make sure this is correct. 36 square root of 3, and again, it's centimeters squared. Okay, I'm going to say this. The only way you're going to get this is if you keep thinking about this relationship here and then practice it on your own. Even with me saying what the answers were, I bet these were a little bit confusing because it's hard to talk about the specific side that I'm working with and we're working with area. You have to work the practice problems. So do the practice problems from this lesson for next time. Keep these relationships in mind.